Hi, my name is Steve Bathiche, and I manage the Applied Sciences Group here at Microsoft. And one of the main areas of research for us is working on smart interactive displays. And today I'm going to show you about 5 different demos, all the way from capturing light from the user to sending light to the user's eyes. Here, let's start here. Here we have a research project where we simply ask the question, what do we do after touch? And as you know, mostly touchscreens today, they can only see the things that are touching directly on the screen. That's why they're called touchscreens. But we want to explore the area above the screen, right above, right over here. And so you can see what we've done is done this front projection system. We have a projector up there and a camera right next to that front projection system. And we have a very special screen here. It's actually a retroreflective screen with this mesh on top of it to diffuse the light that comes from the projector. What the retroreflective screen does also is send a lot of the light from the projector back out to the camera, and thereby any object in the path of that retroreflection is a really strong shadow, allowing us to pick up those images and apply computer vision algorithms to them. Computer vision algorithms that allow me to, for example, do this paint application and draw right above the screen without really touching it, doing simple gestures like the closed loop. So one of the main areas of research for us is actually this, fundamental areas of research for us is building this wedge optical component. And it's a very special flat lens that allows us to put it behind the display very much and capture images very much similar to what you just saw in there. But the images are actually traveling through the display, and now we can see things that are right above the screen and right almost on the screen. So just to give you an example of how those images may look like, this is an example of another wedge that we have, and I'm going to actually hold it up to the camera and capture my hand through the display, and that's exactly what's going to happen here in this coming prototype. As you can see here, here's a transparent OLED and a wedge underneath it, and we have a camera looking through the display, and we're capturing images not all that dissimilar than what you just saw over there in the really bulky front projection prototype. So you can see I can actually, in this prototype, I'm manipulating a mouse. And one of the things that we're able to do is also guesstimate how far we're away, and thereby also incorporating a z dimension to the interaction. And I can move and move the mouse back and forth using gestures right above the screen without touching the screen. So in this interaction, we're able to investigate gestures that are on and above the screen in a much more practical fashion, in a much more thinner form factor, using the wedge component. What we're doing here in this demo is use the wedge optic in reverse and actually put light, shining light down the wedge and controlling and steering where light goes. And if you put an LCD right on top of that wedge, you're able to actually steer a left eye and a right eye image to create an autostereoscopic 3D display. And I'm really excited about this because this has actually never been done before in this form. So let me show you a little bit of the basic principles behind how that actually works. So again, using the same wedge optic, which is not exactly the same, it's actually something that more looks like this without this overhang. But nevertheless, using the same wedge optic, and I take an LED or a flashlight, and you can see that narrow strip of light that's coming out of the display. Well, that narrow strip of light is actually headed towards the camera, which you can imagine is your eye. And if I move that narrow strip to the right, by moving the flashlight to the right, I'm addressing the left eye, right eye, left eye, right eye. And if I do that really fast, and at the same time putting the right image on the LCD, I can create 2 separate images, one for the left eye, one for the right eye, and that's all you need to do to actually get a depth perspective and create a 3D image. And so if I turn now here, and what happens is the Kinect camera that I have up here tracks my head and sees where I am, and immediately turns the display towards me by simply addressing the right set of LEDs that are down here along this edge of the strip. And one of the neat things we're doing, we're not just creating a 3D display, but because we're tracking the head using the Kinect camera relative to the display, we're actually able to reorient or actually change the view of the display as if you're looking through a window at that 3D object that's inside the display. So if I move my head left and right, you can actually see we're re-rendering the 3D scene as if you're looking from the left side and the right side of the display. And even if I move back and forth, it'll look like I'm putting my head in through the window and out through the window. And all the while delivering a 3D autostereoscopic image without glasses. In this demo, we're going to do something very similar, but instead of shooting a left eye and a right eye image, we're going to shoot a person 1 and a person 2 image. Thereby, you can have two people looking at the same screen, but looking at completely two different images. And so I'm looking here at, and I'm actually seeing a teapot, and Moshe, my buddy over here, is person 2. What do you see, Moshe?
I see a skull.
Yeah, so you see something completely different than I do. And even if we got up and moved and switched positions, because we're actually tracking the person and sending the light, I will still see the teapot while my buddy will still see the skull. So one of the known exciting concepts in virtual reality is to digitize a pane of glass. Give the user the sensation that they're actually looking through a real glass window. And we can do that with some of the pieces here we have at Microsoft. Using a Kinect camera and a 3D display, we can track the user's position in relation to the display in 3D space, and then re-render the image as if they're looking through a glass window. And so here, I'm going to turn and look at my position. You see the Kinect camera is actually tracking me, and if I move my head to the left, and if I move my head to the right, it's as if I'm actually looking through a frame. And as you can see here, imagine looking through a picture frame. If I move my head to the left and right, you can see the relationship between my head, the frame, and the person I'm looking at, or the object I'm looking at, actually changes. And if I move up and down, and that is actually what's happening here. So if I point down, you're going to expect me that I'm going to be looking at the ceiling. If I lift my head up, I'm going to be looking at the floor. If I move closer, I'm obviously going to be looking at more of the scene because my view has increased. And you can actually see exactly what's going on by that 3D rendering of what's actually going on. So you can see if I move left, my view changes to the right, and if I move right, my view changes to the left. So putting these pieces together along with 3D input and 3D output, you can start heading towards some of the magical interactions that happen in the envisioning video where the kid walks up in the classroom and puts her hand on the wall and gives her the sensation the person she's talking to and interacting with is on the other side. This is one of the core components that you need in order to do so.